Hi everyone, this is the second video for day 1. We're going to look at the information required to specify a vector. Now here I have drawn 4 vectors: green, blue, red and another kind of blue. What is this? I think this is called teal. So green, teal, red and blue. And by looking at it, none of these are parallel, which means they are all different types of vector. Now remember that a vector means you need magnitude and you need direction. Now, one of the ways we've learned to talk about direction is angle. So I can call this angle the direction. Similarly, I can call this angle the direction. I can call this angle the direction, and I can call this angle the direction. So the direction can be measured as angles and the magnitude can be measured as length. So this arrow has a certain length, this arrow has a certain different length, so that gives you the magnitude. But we have to the length part is pretty clear, but angle, the question is, what's the reference? Right? Because if I tell you the angle between these lines is x, then there's a question of, is it this angle or is it this angle? Right? So when you talk about angles, you always need a reference. So we define the reference as the direction of a vector is the angle it forms with the positive x-axis. That right there, that's the x-axis. Remember, x-axis to the right is positive, it's negative. It's y-axis, positive, negative. So angle it makes with positive x-axis when the starting point is at the origin. So see here, all 4 vectors start from the origin, the point of intersection of x and y. Now we combine this with, remember, the property of translation, right? We can move arrows around. So what does that mean? So if I have a vector somewhere here, A, right, I can use that property to move this vector so that the starting point is at the origin. So I place it here and it's approximately parallel, so they are still the same vector, making sure the length is the same. Let's say the length is 10 here and the length is 10 here. Then I know this is the same vector. And I can measure this angle theta, then that theta gives us the direction of the vector. Now we're gonna, in the second day's video, look more concretely at how to specify the length, how to specify the angle, but that's the basic idea of how the measurement is done. So we're using that nice property that you can move vectors around, up, down, left, right, so that there's no confusion about what angle we're talking about. You take the vector, so the starting point is at the origin, then you take the positive x-axis and you measure this angle. That gives you the direction. So now there's no confusion when you talk about a vector with someone else and you're communicating information, there's no ambiguity. Alright, hopefully that makes sense. Okay. Now, just as like when you learn about numbers or scalars, right? You learn counting numbers and then you start learning operations on that number. One of the first operations you learn is addition. Like for example, 5 plus 3 is 8. 3 minus 7 is negative 4, so on. So the basic operation is usually addition. The subtraction is just adding a negative number. So at that same process, now that you know what a vector is, you know it has a magnitude or direction, the natural question to ask is, what are the operations? So the operations that we are going to study are addition. First, we're going to focus on a graphic addition of vectors. What does that mean is just drawing pictures. It doesn't have to be accurate to scale, just getting a feel of how things work. So there are two ways of doing it. The first one is called parallelogram or tail to tail. Okay. Now when you have this vector, there are two endpoints and we need to make a distinction. The one with the arrowhead is called the head of the vector and the one without it is called the tail. So what the parallelogram law says is if you're adding two vectors, you put them tail to tail. Let's say I have vector A and I have vector B and I want to add them up. Once again, we're going to use the invariance property. So if this is vector B, right, smaller, I'm going to move this so that the tail coincides with the tail of A. And I'm going to move it without rotating it, so just translation. So approximately that's going to be A and that's going to be B. I'm not altering the length and I'm just moving B parallelly. Then what this law says is if you take these two vectors and put them tail to tail, you can complete a parallelogram, which we have studied before. It's a quadrilateral with opposite sides parallel. So this is parallel to this, this is parallel to this. You complete the parallelogram and you draw this diagonal. Then this diagonal is going to be the vector A plus the vector B. Okay. Now one easy way to see why this works is, let's say you are on a street giving directions to somebody. If you start from here and you go right and then you go up, where you end up is going to be sort of on the diagonal, right? So that's the direction you walked in. The next method is called the head to tail method. So like you would think, what you do in this case is take the same vectors. Now I'm going to move it really far so that the head of this vector coincides with the tail. And that's going to be A and that's going to be B. Then this says that if you have them arranged in this configuration and you form this triangle, you take the starting point, the tail of one vector to the head, that's going to be A plus B. So for graphic addition, there are two ways of doing it, parallelogram or head to tail. Or you can call it tail to tail and head to tail. So which is similar to like talking about distances. Going from A to B, then B to C, you could say is the same as going from A to C. Now here's another bonus problem you can work on. Show that both methods give the same result, which is what you would want, right? You don't want how you add things to affect the final answer, right? So what you can do is you can just take two vectors approximately and show why, doing it by the triangle or head to tail should give you the same vector as parallelogram. And keep in mind that when vectors are moved parallelly, they are essentially the same vector. That's the end of day one. Day one has been more qualitative study of what a vector is, how to add it graphically. Day two is going to focus on quantitative addition and really getting down to using trigonometry and Pythagoras theorem to find the sum. And that's it for the second video.